Okay, we're going to talk about adding rational expressions with equal denominators. And as I've mentioned before, rational expressions, that term is simply an expression where it's a fraction. So, for example, if I had 3a plus 2 over 7b, this is a rational expression. This whole thing is really just a fraction. So really what we're doing here is we're adding fractions with equal denominators, except we're going to have some letters involved with that. Now before we take a look at the first example of three examples that I have, something that I want to review. If we have 3a minus parenthesis 7a plus 4. Now how would we handle this? Now remember what I've said before, you've got parentheses here, right? So how do you get rid of parentheses? Well, we use this thing called the distributive property. So what we're going to do is we're going to distribute the minus sign. Okay, and let's go through and do that. So I have the 3a kind of hanging out in front there. Now, I'm going to take a negative. Okay, I've got that negative, and I'm going to take it. What's a negative times a positive? Well, it's a negative. And so it's a negative 7a. Now I'm going to take this negative times that positive, which is negative, and then 4. Now remember, you could also think of that as having a 1 right there. So really you're distributing a negative 1, aren't we? So we're going to take, what I did is I took a negative times a positive, and we get my negative here, and 1 times 7a is 7a. Then I took my negative times my positive, which is negative, and 1 times 4 is 4. And then we could simplify this. 3a minus 7a is 4a minus 4. And I'll kind of emphasize this again as we get into some of those examples that use this type of thing with the distributive property. Now something else that I want to mention before, again, we get into that first example is that is just really reviewing what it means when we're adding fractions with the same denominator. So if I had 3 over 4 plus 1 over 4, okay, what's the answer to that? Well, or maybe a better question is, how would I get the answer to that? Well, I've got common denominators, don't I? So the answer is over 4. And then what do we do with the top numbers? You add them, right? So then I can simplify 3 plus 1, and I get 4 over 4, or in other words, 1. All right, let's take a look at the first example. Now, really what I have here is just simply two fractions. Now, it says add, but you might notice that there's subtraction. But really, addition and subtraction are kind of related, and so is multiplication and division. So watch what I do here, and really in the directions we could have subtract too. It's just whatever the sign is there. All right, do I have a common denominator in these two fractions? And the answer is yes. The common denominator is 2x squared plus y. And I think here what I meant this one over here to be is a y, so I'm going to change that. So both the denominators are 2x squared plus y. All right, now what do I have in the top? Well, I have, so you're going to take your answer, or your denominator, 2x squared plus y, and then you're going to subtract your numerators. So I have 5 minus the 6ax. Now notice that in the top I've got this term and I've got this term. Are they like terms? Answer is no. So there's nothing more I can do with this problem. It's 5 minus 6ax plus, or excuse me, over 2x squared plus y. Take a look at example 2. Now as I look at this example, notice that all the denominators are the same. So I'm simply going to take my problem here and I'm going to write it over that common denominator of a squared plus 7y. Now what do I do in the top? Well, I have 5 minus the 3, right, minus, plus the z. Now is there any simplifying that I can do in the top? And the answer is yes, because surely I can take 5 minus 3, which is 2, plus the z. Now, can I add 2 plus z? Answer is no, because they're unlike terms. So this is my final answer. All right, final example, example 3. Now again, I'm subtracting two fractions. And the two fractions have the same denominator. So 5 times a squared times x, or in other words 5a squared x. Now this is where it gets a little bit tricky. You got to be careful here. So you're going to take 5x plus 7. Now what are we subtracting here? Am I subtracting 3x or am I subtracting this whole value? And the answer to this is you're subtracting this whole value. So it's minus, and to emphasize I'm subtracting that whole value, I'm going to put it in parentheses. Now just like I went over at the beginning, really there's a 1 there. So what are we distributing? A negative 1. Alright? Now, what do I have then? So I'm going to put my division bar, and it's going to be over 5ax squared. So I have the 5x plus 7 kind of hanging out in front. Now, what's a negative 1 times a positive 3x? A negative times a positive is negative, and 1 times 3x is 3x. Now take your negative times your negative, right, because it's a minus 2, so a negative times a negative is positive, and 1 times 2 is 2. Now I'm going to simplify the top. So it's over 5a squared x. Now simplify, let's see, 5x minus 3x is 2x. Positive 7 plus a positive 2, so what's 7 plus 2? Positive 9. And I'm done. This is I cannot simplify this any more than what I have. So the topic is adding rational expressions with equal denominators.